Enzymes. We can't live without them, and neither can anything else. An enzyme is a chain of amino acids folded upon itself into a three-dimensional shape that is held in place by hydrogen bonds, ionic bonds, and disulfide bridges. Different types of enzymes exist because different enzymes have different sequences of amino acids that fold differently upon themselves. This gives each type of enzyme its unique shape. The shape is extremely important because the enzyme shape is what gives it its unique function. These folded protein chains have everything to do with why we are alive. In order for an organism to grow and reproduce, it must acquire and harness energy, achieved through a series of chemical reactions. But how do enzymes relate to chemical reactions? Well, many of these chemical reactions involve molecules that would like to combine to lower their energy. But to achieve this, they must temporarily increase their energy before lowering it. This is called activation energy, and for certain chemical reactions, including the ones needed for life, activation energy may take as long as millions of years to finally achieve, and at that rate, life as we know it could not be possible. Enzymes are the solution to this problem because they facilitate necessary chemical reactions by lowering the activation energy needed. An enzyme does this by grabbing onto reactants, called substrates, in a specific location called the active site, and it clamps the reactions together by wrapping itself around them in what is called an induced fit. After the reaction is done, an enzyme releases the product, then snaps back to its original shape, ready to search for new substrates to catalyze with the same reactants over again. They explain certain dietary issues. A common issue is lactose intolerance, which is marked by the inability to digest lactose. This is caused by the deficiency of the enzyme called lactase in the small intestine. In fact, some enzymes found in snake venom target specific substrates that are useful for the development of medicine. The venom of the Siberian moccasin, for example, scientists have isolated 3 enzymes, one of which is phospholipase, which prevents the coagulation of blood and can be researched and used as blood thinners. But enzymes used in medicine go beyond just snake venom. The synthetic drug Relenza, which treats people with influenza, works by binding to the active site of neuraminidase, an enzyme which cleaves proteins from infected cells and therefore spreads influenza throughout the body. Relenza slows the spread of the disease on the cellular level by inhibiting this enzyme. Because of the enzyme's property of targeting specific substrates, perhaps one day an enzyme could be synthesized to target mutated cancer cells. So the next time you're digesting your dinner or finding the cure for cancer, you should probably thank those little proteins called enzymes.